Hello everyone and welcome to Restoring Time. Today we're going to take this beat up old ring and replate it with our very own nickel plating solution. I'm going to show you how to make it and replate it. Here we go. Okay, so to get started we're just going to need some very basic equipment here. You just need some vinegar. I prefer white distilled vinegar because it has the least amount of impurities and you want to keep this solution as pure as possible. Next up, just some salt. Doesn't have to be anything special, just regular old salt. The next item you're going to need is some nickel battery strip or any kind of nickel that you can find that's really pure. This stuff is 99% pure, so it's really good and it's fairly inexpensive. I believe this roll was just 10 bucks maybe, and you can get it on Amazon and other places. What we're going to do is we're going to cut that roll into small strips, and we're going to use those strips to make anodes and cathodes for our solution. Doesn't matter which one's which, just cut them up into strips that will fit into your container. Okay, now's a good time to mention the power supply on the left. The power supply that I got here is from Amazon. It was around $70, I think. It's adjustable, and I got it because I wanted to fine-tune the adjustments. But realistically, you can do this with a battery or a 5-volt DC power supply that you use to charge your phone. Be careful, don't be sticking any AC in here. That won't work, and it's really likely to get electrocuted, so don't do that. Make sure it's DC. Okay, if you don't know the difference between the two, get yourself a power supply or use a battery. So what I'm going to do now is cut the strips so that they fit into the container that I have. You don't need much of this. We're going to make a really good solution with, I would say, about 1.5 feet of this strip, and it can be used over and over again. So you really don't need a lot. I'm just measuring it out roughly in the container, and we're going to cut one side is going to be for the anode, and the other side is going to be for the cathode. It doesn't matter at all which goes where right now. When we go to plate, it will matter, but for right now, it doesn't matter. You're going to hook one side up to the positive and one side up to the negative. After that, just magic happens on its own. Because this process is destructive, it's going to eat the anode side, the red side, the positive side. It's going to eat it. So because of that, I wanted to make it a little bit beefier. I take the piece of metal stripping and I roll it up a little bit, kind of fold it over on itself so it's thicker and it can last a little longer. If you stick a regular straight piece in there, it's going to still work. This is so that I can leave it a little longer and I can run it at a bit higher voltage and keep it going. All right, let's go ahead and make it. All you're going to need to do is put in a quantity that will work for you and your container. It's not super critical, believe it or not, how much fluid you put in. If you have a tiny small glass, then yeah, you probably only have to put a little bit in, but you want to keep it somewhere around the top of the glass so that your strips can reach far enough in to reach the solution. You don't want to put the ends of your alligator clips in the solution itself. Once you poured in your vinegar and you've poured in your salt, now you got to stir it up. Whether you do it physically with a spoon or use a fancy little magnetic stirrer like this, doesn't really matter. Just dissolve the salt as much as you can. If you do not add salt to your mixture, it won't work actually. It would take probably forever because there's just not enough electrolytes within the vinegar to cause the reaction to happen. So you need to have salt. So don't worry about the type of salt you're using. You can use rock salt, you could use whatever, but you want to try to keep it as pure as possible. That's why I used kosher salt. Table salt would work. I decided not to use iodized table salt, which we have here in the United States. I don't know if iodine would hurt the solution at all, so I just went with kosher salt, which is basically straight salt with an anti-caking agent they put in it. Once it's completely mixed up and it's dissolved, then you can start the process of dissolving your nickel plates. Oh, and one thing I wanted to mention about safety. If you're going to heat this up, which you probably should, it would dissolve it much faster, and you actually want the electrolyte solution to be a little warm when you start doing the electrolysis of the nickel. Don't touch the hot plate. I did it once. You can even see it just above the heated dial there. There's a mark on the plate, and that's a piece of my skin because it gets really, really hot. So when it's in the heated mode and you got it cranked up as much as I do, don't touch that plate. All right, do as I say, not as I do. I'm talking about the purity of the solution, and I reach in here with a pair of rusty needle nose pliers, but I didn't have anything else to get that out of there. And now it's actually pretty hot, so I wanted to not burn my fingers, so I use a pair of rusty needle nose. Maybe I'll plate them next. Okay, now we're going to start the fun stuff. This is actually where the magic and the wizardry begins. We're going to create our solution. So we're going to connect the cathode up to the black side and the anode up to the red side. It doesn't really matter right now, but when we go to plate something later on, we're going to be hooking it up to the black side because that's the side that the nickel that is floating in the solution will float over to. So it's going to travel from the red side to the black side. As far as the voltage goes, I'm going to set it around 12 volts. This power supply automatically does the math for you, but basically wattage, which is at the bottom, 14 watts, is a mathematical formula of volts. I believe it's volts over amperage or volts times amperage. P equals I times E, whatever that is. Long time ago, I went to electronics school, and I'm sad that I don't remember any of it. But the point is that if you crank it way up as far as your voltage goes, your amperage is going to go up as well. Now, DC voltage won't really hurt you. Amperage really won't hurt you as much, even though a 1 amp in AC would kill you dead. In DC, it's not that much, but you still don't want to mess around with it. You will see a spark if you take off one of those alligator clips while it's cranked way up. So turn the power off in between if you're going to be doing any adjustment. Now, as you see, barely here, and I'm going to zoom in, that there is bubbles coming off of the cathode side. And that's because the process is starting, and it's really immediate. It starts right away. What we're looking to do is turn this white fluid that we've created in here, which is just white vinegar and salt, into a sort of light turquoise color. Once it starts turning turquoise, you're good to go. Okay, let me add in one more little bit of safety here. If you notice, there's a mist that's coming off the top there as it's coming up. It is a little bit warm, but it's not boiling necessarily like as in the normal temperature that water boils at. But this is a hydrogen gas. So don't light any cigarettes near here. Don't light a match or anything like that. It would be explosive. I'm just blowing it around with one of my little air blowers here, but keep it away from flame or fire. I guess it's just common sense, but it is hydrogen gas and it is explosive, but it's in such a low quantity. As long as you have enough airspace or a ventilated room, you should be fine. Don't breathe it in. It'll burn your lungs. It is bubbling along quite nicely here, so I decide that I'm going to turn it down somewhere around 8 volts because I was going to be leaving the room for a while. This takes some time, so I could keep it cranked way up, but I thought for safety reasons, why not turn it down just a little bit? So I go down to about 8 volts and leave it there. But if you notice right over my arm that it is already starting to turn turquoise color. We're looking for a darker, richer color than that, but for right now, that's pretty cool that it's already started. This has been about 10 minutes. Okay, I'm going to speed this way up. This is about an hour and a half of time. You can see, if you look closely, the color is starting to go a little bit darker and darker turquoise. I apologize about the slightly rolling shutter effect. That's because I'm speeding it up and my camera shutter is like now flickering compared to the lights. But anyway, pay attention to the color. You'll sort of see that dark turquoise forming at the bottom of the cup. What's also happening now, I want to mention too, is that it is starting to break off little tiny microscopic pieces of nickel in the solution. So what you're going to want to do when you clean this up or when you transfer the liquid out, you want to make sure that you at least filter it. And I'm going to show you that step later on. But we're almost done here with actually making the solution. Once we get to the darker teal color, I think that's good enough. Okay, now it's time to find a candidate for our plating because we're going to try the new solution out that we just made. I was going to use a penny because I thought that's nice, it's copper, and I had a couple pennies and I polished them up. But then I thought, you know what, I've been around YouTube long enough to know that in the comments there was going to be some people hating on me for using a piece of national currency. So I decided to use this old beat up ring that I have that somebody left here. I'm a photographer and one of my models came and was wearing this and left it behind. So I said, hey, let's clean it up. It is just a regular copper ring that has nickel plating on it. The nickel plating is completely gone, and you can see that there's still the black lines in between, but the plating itself is gone. So what we're going to have to do is take it out to the polisher and buff it up enough to remove the nickel plating. So we're going to head out to my garage now, and this is my little jewelry buffing wheel set that I've got. I apologize too again. I'm starting off this whole YouTube thing. It's been a long time since I made YouTube videos. It used to be something I did all the time back around 2012-ish. But it's been a while since I made regular YouTube videos, so I apologize. My camera equipment is really good, but it's been a while since I shot video with it. I usually do photography. Point is that the highlights are just completely blown out with this video clip and all of them that I did out here. So I apologize. It's a bit blown out. I'll fix it for the next one, I promise. But anyway, so what I'm doing is I'm using some basic polishing compound on my little buffing wheel here. For this one, I'm trying to remove the nickel plating. I'm trying to take it off completely. So I'm using a bit more aggressive type of compound to just gently take it off. I mean, you could use something heavier like sandpaper or whatever, but this is just some red compound, which is a pretty mild abrasive, and it'll take off the nickel plating that is still on there. Weirdly, though, it doesn't get down into those cracks between those little bands, but that's okay because it's kind of cool anyway that they're black. It doesn't get plated, and it looks fine at the end. Okay, here I am polishing it up with just the basic buffing wheel. There's no special polish on this at all. I'm just buffing it up. It's a brand new wheel, so it's flying in little pieces. Why I'm doing this, why am I buffing this up so much? Because what happens when you plate something, any material, whether it's nickel, gold, copper, whatever it is you're plating, it will go right over the top of imperfections. So if there's nicks or scratches or gouges, it's not going to make it any better just by plating over the top of it. It'll basically copy whatever is there and make it more pronounced because now we're just plating on top of whatever the imperfection is. So what I'm doing is trying to make it as smooth and shiny as possible so that when the nickel goes onto it, it'll do the same exact thing. It'll then become smooth and shiny. At first, we're going to see very soon that it doesn't quite look smooth and shiny when it first goes on, but then you just come back out and you buff it again and it'll come right up like a mirror. Okay, let's go back inside the workshop. And you can see it's nice and shiny and very pretty. It does have some nicks and gouges on it, but that's okay. It was just an old ring. I just needed something that I could plate. So that is just the raw copper that has been polished up. There is nothing on it at all. There's no plating at all. While I was out there in the garage, I left this running. So it is pretty cooked right now. It is nice and teal colored. So at this point, we can go ahead and stop the solution being created and actually plate the item. Okay, so now we need to wrap a piece of wire around the item that we're going to plate. I tried this with some very thick wire. I had some like 10 gauge wire. I put up solar panels on my house and I have a bunch of wire around. It was way too thick and it was causing what's called shadowing, which is where something's obstructing the molecules from going and hitting the item correctly, the item that you're trying to plate. So because of that, the item will get a black area where there's no plating that's been picked up. So using a finer wire is better actually because you're not using much voltage. We're not putting 100 amps to this thing. We're putting very low voltage through it. So a fine wire will work really well. Off camera, I cleaned up this ring a bit. I wiped off some of the materials that were put on by the buffing wheel and I polished it up a little with some alcohol, some rubbing alcohol. So it's pretty clean even though I've been putting my little grubby fingers all over it. My fingers are also degreased by using the alcohol as well. So now it's time to put it in. Now remember, it's going to go on the cathode side, which is the black side. The other side, I have a rod. I'm going to show you here in a second that I purchased. It's a straight 100% pure nickel rod. It wasn't that much. I believe it was like 15 bucks. But the reason for it is it's extremely thick and very sturdy, and it'll last a very long time. Probably for my entire life I'll be able to use this rod because it doesn't really take much off of it. It's so thick, it's solid. It's a solid rod versus these little strips, which you kind of want them to break apart over time. Oh, well, you're paying attention because you notice that the anode strip disintegrated as I took it out. And when that happened, all those little black pieces started floating around in there. It really did disintegrate and fell apart. So because of that, you want to use some sort of filter. I have some of these really, really fine filters that I use. You notice there's already some fluid in here. This is from, I've done this a few times so far, so I actually have some left over from another go that I had at this. So we're going to put that in there and filter out all those little pieces, because you don't want anything floating in that solution when you go to plate it, because if it does, it might actually stick to the metal and therefore it'll be ruined. So there you go. Those are all the little pieces that were floating around inside there from the nickel. Okay, so now we're going to use our new anode, which is a nickel rod, and it's thick enough it'll last many years. I don't expect it to break down anytime soon. And the alligator clip fits just around it. It's perfect. It's actually really good. For now I set it in here like this, but I remembered that my little magnetic stir plate comes with a attachment in the back that will hold up a piece of metal. I'm going to redo this and you'll see it switch around in here. Right now I just set the ring on the edge of the glass, but I'm going to hang it from a piece of metal across the middle so it hangs more in the middle of the solution instead of hanging up against the wall, because I'm thinking about it, if it's touching the wall it probably won't get good electricity flowing to it. But as soon as I turn on the power, you'll see it immediately kick on and it will start plating the ring. Nobody ever accused me of being a smart person. I should have just used a wooden dowel. I have a bunch of them for when I start doing my watch repair. You should have used a wooden one because it's non-conductive. Because as soon as those two things touch, it's not going to cause a big spark or anything. It's not going to hurt me or anything like that. But they are going to just basically zero out the power supply, and therefore nothing's going to flow. They're not touching right now, so it does actually work. And as you see, there are the bubbles, the magic bubbles that are saying that it is now plating the ring. And there's the magic happening. You can even see it through the glass that it is starting to turn silver. So the nickel is plating onto the ring. Well, we are almost done here. I really wanted to thank you all for coming along and hanging out with me today. I figured out this process by watching YouTube videos, and I'm hoping that my YouTube video can help somebody else that's coming along with me on this journey. My channel will now be focusing mostly on watch restoration and repair. We'll get into that as we go, but for now this is what I wanted to do to try to figure out, well, if I get an old watch that has a really beat up case on it, can I really recover it or fix it with nickel? Can I re-nickel plate it? I don't even know how to do that. It sounds amazing to me. So I figured out that maybe I should learn how to do this step first, because it'll be one of the processes that I need to know when I start doing my final restoration stuff. This is the first video I'm making for this channel, and I'll be referring back to it from time to time. When I'm actually doing my nickel plating on my cases, I'll be like, hey, remember that video I did, my very first video on this channel? Well, here it is. And I can point people back to it to see, so they can see how to do nickel plating themselves if they are looking to get into this. Once again, thanks everybody for coming along. I don't have any Discord or Patreon set up yet. I'm sure I will at some point down the road. But for now, I just kind of wanted to do videos so that I could kind of keep track of how I'm developing as a horologist. New word I learned. Sounds kind of dirty, but it's kind of fun. So we'll get into this later, talking more about all of the escapades as I start doing watch repair. So thanks everybody for coming along, and I will see you all very soon in the next one. Until next time, see ya!